In today's BitSize LeetCode, we're going to take a look at LeetCode question number 7, which is reverse integer. And we will also take a look at a few patterns such as digit extraction and overflow check. So the question is, given an signed 32-bit integer x, return x with its digits reversed, and return 0 if the result overflows, and only use 32-bit signed integers. And some examples are input 123 will give 321 as output, negative 123 will be negative 321, and 120 will be 21, and then the input is outside of the range, then we're going to output 0. And the constraints are must handle 32-bit signed integers, do not use 64-bit types, and return 0 if it overflows. Some of the patterns that we're going to use in the code is, the first one is getting the last digit from an integer. For example, if a digit is given 123, and we will use the pattern x modulo 10 to get the last digit. For example, to get the last digit from 123 as 3, we will do 123 modulo 10, which gives us 3. And then the second pattern is removing the last digit from a number. So which we will accomplish it using the integer division, x integer division by 10. So if you do 123 integer division by 10, it's just going to chop off the last digit, 3, and it just gives us 12. So this is the removing the last digit. And then we will append the digit to the result. We usually start the result from 0, and then we will add our digits to this results using this pattern. Result is equal to result times 10 plus digit. So if the result is 0, that's our first round usually. 0 times 10 plus 3, which is like the first digit that we got, is equal to 3. So the second round, the 3 is going to be 30. The third round is going to be 300. So it's going to append the digit to the result. So that's the one of the main patterns. And then the last pattern is the check for overflow before appending. So we will use this expression if result is greater than int max minus digit, and then integer division by 10 if the result is greater than the boundary of the 32-bit signed integer boundary, then it's going to, we have to return 0. So for example, if the result is this huge number and then digit is 8, and then the above expression will evaluate to true, so it's going to give us overflow, and then we have to return 0. Now let's take a look at the actual code, how this all come together. Now we're going to implement the patterns that we've just learned by completing the following function by filling in the missing logic. And then the missing logic is the patterns that we've just talked about. And then this is the function that we're going to use to implement the reverse integer. And the definition is given as reverse, and then the x is our input. And then we're going to first declare a few constants. For example, int min and int max. This is the boundary of our 32-int bit size boundary. For example, the int min is going to be negative 2 to the power of 31, and then int max is 2 to the 31 minus 1. And then these two numbers are corresponding to these two. It's quite large. So, and then we also declare another variable called result. This is the result that we're going to return at the end. We're going to initialize as empty. And then we will also declare another variable called negative. Negative is equal to if x is smaller than 0. And in this part, if x is smaller than 0, if it's true, negative is going to be true. So we're just going to record negative or not. And then we're going to work with the actual positive number. In order to do that, we will just use absolute value of the x and then store it to x. So now x is positive. Now let's work with that number. So while x is not 0, this is our condition. So we're going to extract the last digit. So in order to extract the last digit, we were just going to x modulo 10. So x modulo 10 is just going to give us the last digit of the number that we're given. And then now we're going to chop off the last digit, x integer division by 10. So this line is going to just chop off the last digit and then give us the x. And then if, so this condition here, it says if something, we're going to return 0. So this is basically if the result that we've gotten is greater than the int max of this number, we have to return 0. But before doing that, let's just return the results first. Result is equal to, so as we've talked about before, result times 10 plus digit. So this is our result. And then let's now write the if statement. If this result is greater than, so int max minus digit, integer division by 10. If this is going to, this expression that we talked about earlier is greater than result, then we will return 0 because it's going to be greater than int max, this upper boundary here. So how do we get this expression here? It's basically the reverse of this expression of this result. Basically, you int max minus digit and divide by this 10. We just going backwards to get this condition. So at the end, when the results are all done, we're going to return it. So we return negative result if negative, else we're going to return the result itself. That's why we stored the negative before, just to see if it's positive or negative. So we return the negative result if it's negative, else it's just the result itself, it's just positive. So that's how we're going to do this problem. Let's just quickly run it. Okay, it ran. Now let's do some test cases. Let's run these test cases. And yes, so the input and then outputs are all correct and it's running as expected. So that's the way that we're going to solve this problem.
That's it for today. Always learn more with less. Hit subscribe and don't miss out on daily videos.